right, folks, it's Bass Action Back in Action here. In this video, we are going to go through some modeling examples. This is just a small sampling of the types of problems that we're going to do, but I'm going to talk about some of the key features and things that we want to be considering as we go along. So in our first example here, we're going to go ahead, we're going to read what's happening here. I'm going to walk you through what to do here, and then you're going to have to do some calculator work. So I'm going to talk you through the calculator work in part B, but you're going to need to do that part at home. Okay, let's read what we've got going on. We have a point P, we're just calling it XY, and it's on the graph of y equals x squared plus 2. Now it's important that you get this in your head that this is a parabola that's been shifted up 2. Got to use our transformations. And D is going to be the distance from this specific point to a point P, this point P back here that's on our graph. So let's just draw a picture. Let's get an idea of what's actually happening here. So I'm going to go ahead and draw in just a rough parabola. This one has been shifted up 2, so I'm just roughing this in. It doesn't have to look nice. I'm going to go ahead and label that point 2, that y-intercept there. Then I'm going to go ahead and put this point 0.06 on here, because that's the point that I'm going to measure my distance from. And then it also says that I'm measuring the distance to a point that's on the parabola. I'm going to even go ahead and switch that out and make that a different color. That red segment is what we're trying to measure the distance between. So I'm going to call that point initially XY, because it said right here that it was a point XY. Now, this is the step that a lot of students skip, and it's really important or the rest of the problem's not going to make any sense. Notice that our point is in XY. We've got 2 variables there, but ultimately we want to find the distance as a function of X. So we need to get rid of this Y that's right here. We're going to do that by coming back up here to the problem and remembering that the equation for the parabola is y equals x squared plus 2. So we can rewrite this ordered pair. The x stays the x, but the y is going to become x squared plus 2. This is now my new ordered pair. So when I go to find my distance, we have to remember our distance formula. Now I'm going to use the 0.06 and the point x comma x squared plus 2. So let's go ahead and get that distance formula going. We're just going to remember our good old distance formula, and we're going to say D equals, oh, I like that. That's a little finer tip. It's going to make it work a little bit better for us. So we're going to subtract our x values. Now we could do 0 minus x, but that's just going to feel weird with the negative x. So let's go the other direction. Let's write this as an x minus 0. So x minus 0 squared. Then we're going to add to that. Now we're going to do the difference between x squared plus 2 and the 6. And I'm going to even write it all out here. When you get good with it, you might be able to do it in your head. Now, be careful. Mine's kind of running into this y-axis, but there is a squared on that part. That's going to be really important for us in a bit. So we're going to keep cleaning this up, and I'm going to say x squared now. That's just my x minus 0 squared. I can even do a middle step here, and I'm going to write this one now as a plus x squared minus 4, and that's squared. Let me extend that root. Now I'm going to keep expanding, and I'll have x squared. Remember, we're going to have to FOIL this, so this is going to become, and be very careful, x to the 4th minus 8x squared plus 16, and I'm going to extend that again. So my final answer for my distance, my new formula in terms of x, is x to the 4th. I can collect these like terms, which is going to be minus 7x squared plus 16. This is our final answer. That is your formula to find the distance as a function of x. Now, if you come over here, you're going to see this funky looking graph. This relates to this question. It says find the value of x that will minimize. That means we're looking for a local minimum. Okay. We want to minimize the distance to this point 0.06. Well, that is exactly what this formula is doing. This formula is automatically finding the distance for any particular value of x. So if I pick a value of x, okay, in fact, I'll make it go this way. If I pick a value for x, some random value for x, my formula will automatically calculate this distance for me. This graph is the graph of the function that we just did. So what you need to do at home is you need to take out your calculator, your graphing calculator, and you're going to enter this entire graph, this entire function into your calculator, and you should get this graph. Once you get this graph, we're going to go ahead and use the calculator to find these points. These local minimums, these are going to be our answers. That was really messy. Those are going to be our answer. So at these x values, it will tell us this minimum distance, and that makes sense. Notice that our function is even. We've got this y-axis symmetry. Both of these are going to be acceptable answers. So in your calculator, we've briefly done this in class. In your calculators, you're going to do the second button. Then you're going to press the trace. That'll be the calc. Then you're going to choose minimum to find the minimum. You will need to set the left and the right bound. It's going to prompt you. So it's going to prompt you for that left and right boundary. What it's going to do is it's probably going to give you a little flashing cursor, and you're going to set your cursor for the left bound to the left of your 0. Then you're going to arrow over. You're going to get it to the right of your 0, and then it will guess. It's going to give you a nice ordered pair, and we're going to round that to 3 decimal places. So you should be able to get this answer in your calculator. If you can't get this answer in your calculator, you need to come see me, okay? So our final answer is at, and we're going to say plus or minus for this problem, 1.871. So at x equals plus or minus 1.871, the minimum distance is 1.936 units, okay? So that's our first one. You're going to have a practice problem that's going to be virtually identical, but with new numbers for you to practice. All right, let's take a look at another one. This one's pretty complicated. I got a lot going on this problem, but this is one that students often need to see a couple times, hence the video. Okay, so this time I've got a rectangle, so I know that ultimately I'm going to draw a rectangle, and then it starts to tell me where all these corners are. There's one corner, there's another corner, then the remaining 2 corners. And then it tells me that it's going to be on a semicircle, the center is at origin, and the radius is going to be 5. It also says that that semicircle is above the x-axis. So before I even do anything else on this problem, I want to go ahead and get the equation for the semicircle. Remember, we're going to start with the equation for the circle, which is going to be x squared plus y squared equals 25, because I got to square that radius. I'm going to skip some steps because we've done this one so many times. I'm going to do the square root here then of 25 minus x squared, and I automatically know that I'm choosing the positive because it said it was above the x-axis. All right, now that I have that, let's go ahead and start drawing our picture. So if I draw my picture, got my little XY axis there. I'm going to just rough in a semicircle. It doesn't even have to be beautiful. It's okay. Mine's not very great today. I'm going to label my intercepts. So I have a 5 and I have a -5 because remember my circle had a radius of 5. So I can go ahead and label those. I could even, if I wanted, I could put a 5 up top. It's no big deal. Now my rectangle has corners that are on the circle and then also corners that are on the axes. Now, since it's a semicircle and it's a rectangle, I know that these 2 distances have to be the same. So what we're going to do is we're going to label this point XY, because this point is on the semicircle and I went over X and I went up Y. Okay, that's the first part we got to really get into our head, is we go over X, up Y, and boom, we're on the semicircle. That means that this is some length of x, and also this over here is a length of x. Now, this throws students off a little bit because I'm going in the negative direction. Slow this down, pause it if you need. I'm going in the negative direction, but it's a length, so I'm writing it as a positive x. I have a vertical distance here of y. So this is y. So the sides of my rectangle are 2x and y. Now again, I need this to be, if I look up here in my directions, I'm going to need this to be as a function of x. Right now, I have two variables happening here. So I'm going to do the same step that I did up here. So remember, up here on this problem, we rewrote the xy all in terms of x, using the x and the equation for y. We're going to do the same thing down here. I have an x, it gets to stay x, but the y is now going to become my equation for my semicircle because any y value was on the semicircle. So now I'm going to write this here is 25 minus x squared. Now this one looks more complicated than the other one, but weirdly this one turns out to be a whole lot easier because the area of my rectangle is going to be, I don't want this to end up being too big here, the area of my rectangle is going to end up being length times width. Well, that means that my area has to be a function. I'm going to say a of x to remind me it's an x value. The length is 2 of these x's long because it's on both sides, so 2x. And the height of my rectangle is this y, which is the 25, square root of 25 minus x squared. So 25 minus x squared. This is your final answer. There is no more simplifying that can happen with this answer. So what I've done here again is this is our function that if I have a value for x and I substitute it in, it will automatically tell me the area of this rectangle that I've created, okay? Now, this formula, that we've just created, I've given you the graph right here. Before I get to this question, I wanted to have this little discussion up here for part B, okay? Part B says find the domain and the implied domain for this function. Remember, domain is always going to just be the domain of the function itself. So we could look at this function and say, hey, I know that under this radical, it needs to stay positive, and we've done lots and lots and lots of these to say that I need under the radical to stay positive, and I could get my domain to be -5 to 5. Now, if you're looking ahead, this domain for the function makes sense because remember, this is the graph of this function, and we can see it is going from -5 to 5. So this makes sense. Okay, now implied domain says, what are the actual values for x that I can choose that will physically make this rectangle happen? Okay, I can't actually choose a negative value for x. So my only possible values for x can only be these positive values. But remember, if I choose 0 for x, my area will be 0. If I choose 5 for x, I'm also going to get 0 for my area. So my implied domain is not inclusive, will be 0 to 5. Okay? So when we're looking at our graph and we're analyzing this, we're actually only ever going to analyze this part that's in the first quadrant. Now, I do like to label this axis. Let's go ahead and label this and remind ourselves that these are the x values that I'm choosing, and the y value is going to give me area. Okay? If we repeat the process that you did before, this is the same process that that I instructed you to do up here. We're going to do second. We're going to hit the trace. That'll give you the calculator. But instead of choosing min, this time I want to maximize the area. So I want to maximize. It's going to be a local. We're maximizing the area. We want it to find this point. Again, the calculator is probably going to ask you to do that left and right bound. So you're going to set your cursor to the left. You're going to set your cursor to the right. You'll just arrow left and right and then let it guess. It's going to give you the ordered pair, and we're going to go to 3 decimal places, 3.536, 25. So we're going to say at x equal 3.536, the max area is 25 units squared. And that's that answer. Okay? Again, there's going to be another one on the other side of your notes for you to practice that's going to be very similar. Although, I'll be honest, the one that I gave you in practice is a little easier. You don't have to do the semicircle again. You get just a parabola there. All right, last one that I want to look at is we could do it in the format that I've already shown you, but I want to show you how to do this with just some basic Algebra 1 skills. So in this last one, we want to find a point, which means we're looking for an XY pair when we're done. It's going to be on this line, and it needs to be the closest to this point right here. So let's draw a rough picture of what this looks like, okay? I have a positive sloping line with a positive y-intercept, so I'm just going to rough that in. Ooh, that was a wonky looking line, but we're going to go with it. My point -5, 6, I'm going to stick that point just somewhere here in the 4th quadrant. Beautiful. Now, what we want to remember is from our geometry days that the distance from a point to a line has to be measured on a perpendicular. If I want to get that distance, this needs to be perpendicular. The answer to my problem is this point of intersection right here. This point is the answer. So we have the equation for the red line. It's right here. We need the equation for this little perpendicular line, but we know its slope because it's the opposite reciprocal, and we know the point that it goes through right here. So the first thing that we're going to do is we're going to write the equation for that line. So we're going to say y minus 6, just reviewing that point slope form. Our slope, our perpendicular slope, has to be a -4. So I'm going to say -4. Then I'm going to say x plus 5. I'm going to rearrange this real quick. -4x minus 20 plus 6. Now, this equation and this equation, I just set those two equal to each other, and I can start solving. And when I find their point of intersection, I will have my answer, okay? So I'm going to say -4x minus 14 equals 1/4 x plus 3. We get to go back and remember that we can clear these fractions and make our life so much easier. And we'll have negatives. Oops, I didn't mean to say that. Let me erase that. Oops, I got ahead of myself. Okay, I'm going to say, yep, -16x. Now I'm going to say minus 56. When I distribute all the way over, I'm going to get an x plus a 12. Just keep solving. 17x is going to be a -68. So x is going to be -4. I'm going to substitute that answer back in. Now, we can choose either side of this. I'm going to pick this one because it's definitely the easier of the two to work with. So y is going to be -4 times -4 minus 14, which is going to give me a positive 2. So my final answer is -4, 2. That is the point that is going to be on this line that will be closest to our other point. Okay, so now you're going to have, as you can see here at the bottom, it says turn the page. You will have 3 more problems that mimic these 3 for you to practice.